Hello everybody. Today we are going to discuss some questions related to the chapter Nuclei. The nucleus of atom is at the center part and there are some questions related to the radius, energy and mostly related to binding energy. That means nuclear reactions or atom bomb or nuclear fuels or energy production starts, etc. We may consider some questions related to this chapter. We may start with the first question. The radius of germanium nuclide is measured to be twice the radius of beryllium. Whose mass number is given. The number of nucleons in germanium. Nucleons means, as you know, the number of particles in the nucleus. That means total number of protons and neutrons, and this already actually the mass number. You have to calculate the mass number. We have the relation to find the radius of an atom as R equals R0 A raised to 1 by 3. Where A is the mass number, size of nucleus. Then we have to calculate the mass number of one of its. R of germanium, by we may write like this, R cube equals R0 cube A. That means R cube proportional to A. Then radius of germanium divided by radius of beryllium equal to the cube equal to A of germanium by A of beryllium. Here, radius of germanium nuclide is measured to be twice the radius of beryllium. I may calculate germanium as 2R, beryllium radius as R, twice the radius of germanium, cube, equals. We have to calculate the mass number of germanium divided by the mass number of beryllium is 9, divided by 9. R cancels, we will get 2 cube equals mass number or total nuclides in germanium divided by 9. 2 cube is 8. A of germanium equals 2 cube 8 into 9 is equal to 72. That is the total number of nuclides in germanium atom. Now there is second question. Find the amount of energy released as mass of 2 AMU, atomic mass unit, is converted into energy. This is the nuclear energy form, the basic principle in atom bomb, nuclear energy, etc. Energy equivalent of 2 AMU. In simple form, the energy can be written like this. Energy in AMU into 931 MeV. Energy in AMU is 2. 2 into 931 MeV. Here the answer is all are in joule. Something are in MeV, but it is 2 into 931, not 931 or 931.5. So 2 into 931 into MeV means mega electron volt. 1.6 into 10 raised to minus 13. EV is 1.6 into 10 raised to minus 19. Mega means into 10 raised to 6. This is why you got it as 1.6 into 10 raised to minus 13. Hence, on multiplication, we will get 3.2 into 931 into 10 raised to minus 13. That is 3 into 9, almost 20, and followed by nearly it will be 3000 into 10 power minus 13. That means 3 into 10 raised to minus 10 joule. The answer is to be option B. It is 3 into 10 raised to minus 10 joule. Next is question number 3. The mass defect in a nucleus is 3.5 MeV. This mass defect is converted into energy. That is the basic principle in energy production, nuclear energy production. Then the binding energy required to bind the nucleons together. Energy equivalent of 3.5 AMU. Energy is simply in AMU into 931 or maybe 931.5, like that. The energy is energy equivalent of 3.5 AMU. 3.5 into 931. This nearly below 3500. That means nearly 3260.25 MeV. The correct answer is option C. It is 3260 points. Now it is question number 4. The energy of 21 gram of uranium is equal to energy of 21 gram. Energy is actually the Einstein's mass energy equation is to be given equal to mc square. M here it is 21 gram converted into kilogram is 10 raised to minus 3. Then speed of light 3 into 10 raised to 8 whole square. The energy is 21 into 9 into 10 raised to minus 3 into 10 raised to 16. 21 to 9 is 189. Then it is 10 raised to 13. That makes joule. Energy equivalent of 21 gram is option C 189 into 10 raised to 13 joule. Now the last question, question number 5. A sample having half-life of 3.8 days. After how many days the sample will become 1 by 8 the original substance? This is called radioactive disintegration, self-disintegration of a heavy element into smaller ones by the emission of alpha, beta or gamma rays. That is called the radioactive decay. There is a relation connecting it. Number of elements after an n half intervals is, n half periods is n0 by 2 raised to n. n0 is the original number of atoms. Here, n0 by 2 raised to n equals 1 by 8 of n0. After how many days 1 by 8 of the sample will remain? That means we may calculate how many half-lives. n0 cancels. 1 by 2 raised to n equals 1 by 2 raised to 3. That is n equal to 3. It will take 3 half-lives. And the original number is to be 3.8 days for each half-life. That is n half-lives. n into 3.8. n here it is 3. 3 into 3.8. That is 3 into 3.8 which is equal to 11.4. The correct answer is option A. It is 11.4. Work hard based on this chapter, namely nuclei. There are certain questions related to energy productions, mostly related to mass defect, binding energy, energy production, etc. Okay, work hard. Best wishes to all of you. God bless you. Thank you.